We've seen that the Laplace transform of the equation y prime minus 2y equals e to the 3t is 1 over s minus 3 times s minus 2 plus y naught over s minus 2. We know that 1 over s minus 2 is the Laplace transform of an e to the 2t, and of course we know from looking at the left-hand side of the equation that e to the 2t is a solution to the homogeneous equation. So this is consistent with what we expect of this solution. Let's see what to do with this 1 over s minus 3 times s minus 2. Now we're aware of partial fractions. They've been used previously in the course. So let's just write 1 over s minus 3 times s minus 2 equals a over s minus 3 plus b over s minus 2. And then we can write that as a times s minus 2 plus b times s minus 3 over s minus 3 times s minus 2. And that equals a plus b multiplied by s, and then minus 2a minus 3b over s minus 2 times s minus 3. Not going to write them out, we know what's in the denominator. But that should then equal our original 1 over s minus 2 times s minus 3, leading us to the system of equations. A plus b times s has to be 0 because there's no s term on this side. So a plus b equals 0. Negative 2a minus 3b equals 0. This tells us that a equals negative b, and if we want to put in negative a for b or negative b for a, we can solve this equation for that variable. And we'll do that on a separate sheet, and I'll write it out in advance because this is a very common and at this point should be a pretty trivial process. Then we'll see what that tells us about the solution to the equation. Okay, I wrote this down carelessly. The negative 2a minus 3b is clearly 1, not 0. Our system of equations is just a plus b equals 0, negative 2a minus 3b equals 1, and I'm not going to point out the details of the solution. If b is negative 1 and a is 1, these two equations are both satisfied, and certainly you know how to do this. Now, what does this tell us? Remember that what we've done is partial fractions decomposition of the expression 1 over s minus 3 times s minus 2 from the Laplace transform of y. So that now, since a is equal to 1 and b to negative 1, this fraction becomes 1 over s minus 3 minus 1 over s minus 2 plus y naught times 1 over s minus 2. Now recalling that the Laplace transform of e to the alpha t is 1 over s minus s greater than alpha, 1 over s minus 2 must be the Laplace transform of what? Well, that's just this with alpha equal to 2. This must be then e to the 2t. And 1 over s minus 3 is the Laplace transform of e to the 3t. Once more, I'm making use of the linearity of the Laplace transform when I say then that if the Laplace transform of y is this minus this plus this, our conclusion is that y is whatever is transformed into 1 over s minus 3, which is e to the 3t, minus whatever is transformed into 1 over s minus 2, and that is e to the 2t, plus y naught e to the 2t. The solution is easily enough verified. Let's first verify the initial condition. Y of 0 equals y naught. Okay, if t equals 0, then every one of these exponentials is 0. It is 1. So we get 1 minus 1 plus y naught. 1 minus 1 is 0. That leaves us y naught. Y of 0 does equal y naught. Now to verify that this is a solution to the equation, I'm going to write this as e to the 3t minus, let's do it plus, y naught minus 1 multiplied by e to the 2t. And let me just observe that e to the 2t plugged into the left-hand side of this equation gives us 2e to the 2t, the derivative of e to the 2t being 2e to the 2t, minus 2 times e to the 2t. That gives us 0. It's 2e to the 2t minus 2e to the 2t. And it doesn't matter if there's a y naught minus 1 in front of the e to the 2t. It's going to carry through to both of these terms. And this much of our solution gives us 0. What about e to the 3t? Well, y prime would then be, if y is e to the 3t, y prime would be 3e to the 3t. So we'd have 3e to the 3t minus 2 times e to the 3t. So 3e to the 2t minus 2e to the 2t. Saying it wrong. 3e to the 3t minus 2e to the 3t equals e to the 3t. So y of 0 equals y naught, and y prime minus 2y equals e to the 3t. Now I've checked it. I've checked it by pointing. If you didn't understand everything I said, write it out. Plug 0 in for t and verify that you get y naught, and plug e to the 3t plus the quantity y naught minus 1 e to the 2t into the equation and see that it's so.